2.2 number 33 gives me y equals 2x to the fourth minus 3 at the point 1, negative 1. We want to know the value of the derivative at this x value. So I'm going to keep the 2 out, do power base 1 less power. The derivative of this constant is 0. So that makes dy dx into 8x to the third. What is the x value that I need to substitute in? 1. So that makes the slope 8. It also asks you to verify using a graphing utility. So get out your graphing calculator and see if you can do this. Math 8 might help you get to derivatives. Okay, this is 41. You'll notice we're trying to find the derivative of a quotient. If you knew the quotient rule, u over v equaling v u prime minus u v prime all over v squared, then you could take the derivative of a quotient. That is part of the next section, however. We have not got to quotients. So you have to creatively come up with another approach. What are all of these divided by? So can I divide each of these individually by x? Now I haven't taken a derivative, so I don't want to mark it as f prime yet. So what's its derivative? What is the function? 4x squared plus 3x, I believe. That's the function. So basically I took a quotient and turned it into a non-quotient. Now I should be able to find the derivative. You're going to do power base 1 less power. The derivative of 3x is 3. So the answer that we're looking for is 8x plus 3. Okay, 31 wants a derivative when x is 2. Before I even find the derivative, I'm going to rewrite this as 8x to the negative 2. I'm hoping you can tell me that 8 times negative 2 is negative 16, and 1 less power being negative 3. I'll never accept exponents that are negative, so you're going to have to move them to the other side. So I rewrote f of x as 8x to the negative 2. Then I kept the 8 out and I did power base 1 less power. Then I rewrote it and I moved the negative exponent to the bottom. At this time I'm going to put what value in for x? 2. So that's negative 16 over 8, because that's to the third power. And the answer is negative 2 on 31. For 35, I need to find the derivative of h of theta, so I call it h prime. Keep the 4 factored out front as a constant factor. The derivative of sine is cosine. The derivative of theta with respect to theta is 1. Think of theta like an x. So you get 4 cosine minus 1. And what x value do you put in? You're supposed to know that the cosine of 0 is 1. And you get a value of 3 for 35. Because we do not know the quotient rule, we need to simplify this first. Because they are all divided by x squared, I'm going to divide them all by x squared. What does this simplify to give me? X minus 3 plus 4x to the negative 2. Now I've rewritten it, but I have not taken its derivative. Now I'm going to take the derivative. The derivative of x is 1. The derivative of a constant is 0. 4 is a constant factor. You keep it out and you do power base 1 less power. So you get 1. I believe that's minus 8x to the negative 3. I told you I'll never accept negative exponents, so please move it, and there's your answer. Now, it could be written different ways. Could 1 be written as x cubed over x cubed? Is that still a 1? So now you have it written as a common denominator. This also is an acceptable answer. On multiple choice tests, you're not going to have 2 correct answers, so you need to know how to change one answer into the same answer with in a different form. Okay, I took 6 over 5x cubed. I cubed the 5 and I cubed the x, so it became 6 over 125x to the negative 3. That's my rewrite. Then I took the derivative. I kept the constant out front, did power base 1 less power, and I get this. So when I simplify it, because I can't leave negative exponents, this is the answer I believe they have in the book for number 27. This is the ones where you rewrite, take the derivative, and then simplify. To do these, you have to remember what your derivatives are. So the pi over 2 is a constant. So the derivative of sine is cosine minus, and the derivative of cosine is negative sine. So my answer is going to be pi over 2 cosine theta plus sine theta. And that really is not dy dx, that's dy d theta, because I took the derivative with respect to theta. For 51, you want to find the derivative. So I'm going to do power base 1 less power. That becomes this because it cannot accept negative exponents. Keep the negative 2 out as a constant factor. The derivative of e to the x is e to the x. It's the only function whose derivative is itself. And so now we have the derivative on 51. For 95, this is the projectile motion formula. I'm going to read 95. A coin drops from the top of a 1,362 foot tall building. That tells me it's in feet. If it's in feet, then this right here is either going to be negative 16, or if it's in meters, negative 4.9. Because it says feet, I know that I'm going to put in place here a negative 16. Now, what goes in place of the initial velocity? Sub O means initial. If you throw an object up, you give it an positive initial velocity. If you throw it downward, you give it a negative initial velocity. This says the object or coin was dropped. That means the initial velocity is 0. It does say from the top of a 1,362 foot building, which happens to be the height of the original World Trade Center. Now, that gives me my position function to be negative 16t squared plus 1362. That is called the position function. That's part of the answer for part A. They also want the velocity function. So to go from position to velocity, you take the derivative. What's 16 times 2? And what's the derivative of this constant? 0, right? So I think now I should have both the position and the velocity function for part A. Okay, part B wants us to find the average velocity on a time interval from 1 to 2. Average velocity, you need to know, is the change in position over the change in time. That means the position at time 2 minus the position at time 1 over the change in time, 2 seconds to 1 second would be 1 second. So, if I know my position function to be this, how can I find the position at time 2? By plugging in a 2. So I'm going to put a 2 in. 2 squared is 4 times 16 is 64, but it's negative. I think that becomes 1298. On bottom, obviously, it's a 1. Now, how do I find position at time 1? Well, I do the same thing, but instead of putting in a 2 for time, now I'm going to put in a 1. So I get negative 16 plus 1362, which is what? 13 what? So if you put in a 1, you get 1346. If you subtract, I think you get a negative 48. And that is what's called the average velocity on this time interval, and that would be in feet per second. So that's the average velocity. Now we also have to find the instantaneous velocity. The instantaneous velocity, we're going to use our velocity formula, which in this problem is simply negative 32t. I want the velocity at the 2 endpoints. It wants the instantaneous velocity at time 1, and it wants the instantaneous velocity at time 2. So the instantaneous velocity at time 1 is negative 32 feet per second. The instantaneous velocity at time 2 is negative 64 feet per second. Hopefully you notice that the average velocity is between the two instantaneous velocities. Now this is the answer for part B. Actually, B wanted the average, and this is the answer. Instantaneous is part C. Part D wants to know the time required for the coin to hit the ground and the velocity of the coin upon impact. To do this, I'm going to rewrite my position and velocity function on the next slide. So, if I copy over my position function, x of t equals negative 16t squared plus 1362. And my velocity function, I think, was negative 32t. I need to find the time it takes to hit the ground. X of t is the height above the ground. What's the height above the ground when it hits the ground? 0. Add the 16t squared over. Solve it. You would divide by 16 and take the square root. And I believe that gives you about 9.22. Is it 6? Now, that's the time it takes to hit the ground. To find the velocity when it hits the ground, you need the velocity at that time. So you're going to put in 9.226, 9.226. And that tells me the velocity when it hits the ground is approximately negative 295.242 feet per second. And these are my two answers for part D. I hope these help. Good luck.